So today we're looking at topic 5.5, but I'm going to discuss 5.4 and 5.5 together, which is one-step inequalities. All right, one-step inequalities. So what we talked about yesterday was x is no longer equals to just one number, but it will be greater than or equals to 7. So that means that if I was to say this in words, I would say that you need to have at least 7 of something. So you need to bring at least 7 pencils to school. If I say at least something, then that would be greater than or equals to 7. So how would I graph that? What would I do? Would this be an open or a closed circle on the 7? Bailey? Closed, because it is at least 7, which means or equals to 7. 7 is part of my solution. And it's greater than or equals to, so that means we shade to the right. Greater than is always to the right, because those are the numbers greater on a number line, right? When you go to the right, things get greater, they get bigger. What if I have x is, your mom says you can have, well, we'll just do x is less than 5. So how would I graph that? Open or closed circle? Open circle, right? Shaded to the left, because x is less than 5. 5 is not part of my solution, right? Therefore, it has to be an open circle. Okay, that was the basics that we talked about yesterday. We saw how that worked. And then I said x minus 2 is less than 7. So we solve these by doing the same thing we did with equations. We make our t-charts. I get rid of minus 2 by doing what? Adding 2. And x is less than 9. So then I graph it. Open or close circle? Open. Shaded what direction? To the left, because we read that as x is less than 9. Alrighty? So that's what we did yesterday. With topic 5.4 was one-step adding and subtracting. Topic 5.5 now says we are dividing and multiplying. So we'll go n over 7 is greater than 10. So anybody got any ideas on how we solve this? Daniel? Right, we're going to multiply both sides by 7, because we get rid of division by doing the inverse operation. And is going to be greater than 70. Simple, right? You think it's going to be that simple, or you think there's going to be a twist? Yeah, there's a twist. When multiplying or dividing by a negative number, our inequality symbol flips. So let's look at what that means. I get rid of the -2 by doing what? Dividing both sides by -2, right? They're multiplying, so I got to do the inverse operation. Divide by -2. These cancel out, leaves me with x. What's 10 divided by -2? -5. All right. So let's think about this. The number to the right here was a positive number, right? It was a positive number. But when I divide or multiplied by a negative, it flipped to the negative side, didn't it? So therefore, we flip our symbol from a less than or equals to a greater than or equals to. I know, it's tricky, isn't it? So when multiplying or dividing by a negative number, we flip the symbol. That is something you need to write down. Put a big star over it. That is the only trick with this. The only trick. I'm not going to trick you anymore. Question, Maya? Well, I just told you that this 10 to the right of the inequality symbol was positive, right? But when I multiply or divide by a positive and a negative, it flips the sign. So 10, when I divided, became a negative. The positive became a negative. And so since that flipped to the negative side of the number line, I have to flip my inequality symbol. Yes, Noah? No, it could just be less than or greater than. Do what? Yeah. It will always stay equal to, right? No. It's not. With a line underneath it. Oh, you're saying the symbol doesn't, like, we don't lose this part of it? Yeah. Correct. The symbol stays less than or equals to or greater than or equals to. Yes. All right, so let's look at another one. Let's say you've got x over -5 is less than or equals to 10. So go ahead and work it out. Okay, we got answers. No, what you got? X is greater than or equals to -50. Very good. Because we are getting rid of this division by multiplying -5. And when I multiply or negative or divide by a negative, my symbol flipped, didn't it? Okay, what if I give you this though? 2x is less than -20. So when I solve this one, I get rid of the 2 by dividing by 2. -20 divided by 2 is -10. Does my inequality symbol flip on that one? No, why, Maya? Right, it stayed negative on that right side, didn't it? So there's no reason to flip it. Very good. So just because one of them's negative doesn't mean we always flip it. It's if we are multiplying or dividing by a negative, right there, that step. That's when we would flip it. So this one, we don't. Good job. Okay. We got some word problems. I knew you'd be excited about that. So let's look at some of the wording. This one we just had this issue last period because look at how this is worded. It says you had a bag of fruit snacks that you share with 4 friends. Each of you get no more than 2 fruit snacks. So we would say, right, you're taking the fruit snacks, X, and you're dividing them up amongst how many people? 5 people. You're like, what? You just said, yeah. There's 4 friends, but we're dividing them up amongst 5 people because you want some too, right? You and 4 friends. So be careful on wordings like that. Now, you guys get less than or equals to 2. That means we multiply or divide. We're going to multiply by 5, right? And X is less than or equals to 10. What does that mean? That means that there are at least less than or equals to, 10 fruit snacks in the bag, which means they put a maximum of 10 fruit snacks in the bag, but there could be less as well. So your friends might get 2, but they might get less. Does that make sense? So on these, at least it gives you the inequality. And so read the wording so you know how to match it up. Here's multiplying and dividing negatives. All right, so now this one, you have to figure out the inequality that goes with the situation. So a type of fish for your aquarium costs $6 each. You can spend at most $42. So that means you're going to the store with $42. You cannot spend more than $42. So what symbol are we going to put in here? What do you think, Kyle? So you say we're going to spend X. What we're going to spend over here, X, is going to be greater than $42? No, because we can spend at most. I know you see the word most and you think greater than, but that's the most you can spend. So it's got to be less than or equals to, because you can spend $42, right? Or you can spend less than your $42, but you can't spend more than your $42. Now, what are we doing with the 6? If it says $6 each, what operation does that tell us? What'd you say? Multiply. So that's going to be 6x. Now, yes, you're going to divide to solve it, aren't you? That's what a lot of people see. They think, well, I'm going to take 42 and divide it by 6. Yes, that's how you solve it. But how do we set up an equation that shows us what we do before we solve it? And then we make our t-chart and solve. Okay? So you got to translate some of these as well. Be careful. If you get stuck, let me know. I'm going to put in Google Classroom some notes that kind of help you with the vocabulary. So if you get stuck and not sure what symbol to use with what terms, go back and look at those notes in Google Classroom, okay? All right. Remainder of the time.